All right, so let's get started. Hello, everybody, and thank you for taking the time to join this webinar. My name is Jani Virkkula. I'm Content Marketing Director at SSH.com. And before moving on to the topic of the day, a couple of practical things. All attendees are muted, so if you have any questions during this webinar, please send them through the chat option of the GoToWebinar client or the prompt. We have reserved some time at the end of this webinar to go through any questions that you might have. And the topic of today is the evolution of third-party access, and we are going to go through that topic by demonstrating and illustrating you some real-life use cases at what the best way of taking care of and handling and managing third-party access, what some of the best practices are to take care of that. And on that note, we have actually selected theme for today as well. And the theme is that access shouldn't get in the way of productive work. So it goes without saying that controlling and managing third-party access is really important, but we believe that you should be able to do that without any operational friction or business downtime. And today with me, we have a couple of experts, Keith Uber from Ubisecure and Markku Rossi from SSH.com. So gentlemen, the floor is all yours.
Thanks very much. Hi, everybody. My name is Keith Uber, and I'm the VP of Customer Success at Ubisecure. Ubisecure is a vendor of identity and access management products, and we've been doing this since 2002. We have a range of products around our identity server and identity APIs to help developers and businesses get their users managed as part of a planned approach within their systems. Ubisecure serves large organizations and governments, and we've been doing this successfully across many different markets for many different use cases. But more and more we're seeing, what we'll be discussing today is when a third party needs to get access to some internal resources. And I introduce now to you Markku Rossi.
Hello everybody, my name is Markku Rossi and I'm the CDO of SSH.com. And SSH.com is the inventor of the Secure Shell protocol, and we are still selling commercial Secure Shell client and server products. In addition for that, we have been concentrating on the access management problems, starting from the privileged access management around Secure Shell protocol, and for that domain, we have also developed SSH Universal Key Manager product that takes care of analyzing the network, the usage of SSH keys, and establishing processes how the SSH key-based access can be provisioned. In addition for that, the latest addition for our product portfolio is PrivX, which is a cloud-native, scalable, lean access management solution that uses short-lived ephemeral certificate to provide access for Windows and Unix boxes on cloud environments. At SSH, my personal responsibilities are around software and technology strategy, and I'm interested in security, cloud computing, and scalability.
Great, so let's get started on today's topic. We're going to start with an example of what can go wrong with third-party access. We've seen many companies end up in headlines for all the wrong reasons. A typical example is when a company has granted access to some third party. It might be a consulting company or an outsourced service provider, and they get access through that to internal systems, and they get the ability to change data, or in the worst case scenario, steal user data. And we want to make sure that your company and your brands don't end up in the headlines like this. So we're going to look at today the evolution of third-party access by looking at 4 different use cases, 4 different customer examples, so that you avoid these type of headlines, and instead you're in the press for all the right reasons.
Right. So maybe we start with the first use case, and this would be maybe the, let's say, the most traditional example of third-party access. And here the setup really is that we have the elevators installed in the buildings. And now if we imagine the situation that you are inside the elevator and something goes wrong, what can you do? Well, luckily nowadays the elevators are all connected. There is some sort of a connection to the maintenance engineers who can diagnose the system and see what kind of fault there is and hopefully even remotely fix the problem situation.
Yeah, many times it's remote diagnostics, but also remote repair and control. And this use case can be for elevators, for escalators, for anywhere where you're moving people around. And not only is it a great problem for the person who's stuck in an elevator when it's not working and they're finding it hard to breathe, but it's for all the other people waiting to get from point A to point B. So in these situations, you want to make sure that the service technician can get remote access to look at the system from wherever they are in the world as quickly as possible, so that people can keep on moving.
Normally, in this kind of setups, the elevators are somewhat isolated from the building infrastructure, and there are fixed lines, so there are VPN connections, so that the actual elevator operators and the maintenance engineers can do the diagnostics. So this is sort of a simple use case for the third-party access. The connections and the internet connections and lines are somewhat pre-baked, and the access provisioning is configured when the elevator is installed and you make the service agreement with the company who is operating that.
In some cases, the actual manufacturer of the elevator may be involved. Service may be outsourced to a reseller or a third-party partner, and then the actual building owner may have access to certain parts of the system for monitoring purposes. So there is even a role component in this type of system. Going on with the evolution, so if we think of the elevator use case, we can move that forward into a more sophisticated environment, and we're going to look at a factory environment. So this might be a manufacturing environment where you have a production line creating materials either through robotics or foodstuffs for packaging, and we're seeing this more and more. We're talking about the Industry 4.0.
Yeah, so the factories used to be, well, they still are very physical, and they are physical equipment that are taking care of the product manufacturing and the assembly lines. They used to be maintained locally, and they were very low tech in that sense, that the maintenance mean some physical assistance and some fixing. But now with the Industry 4.0, the trend is that everything seems to be moving into digital world, even in the physical factories, and that includes overall the factory building, but also the equipment that are included inside, and there are multiple drivers starting from data collection, so that you can optimize the production pipeline and see what are the bottlenecks. You can have the sensors in the equipment, and then you can do preventive maintenance, seeing that there's something wrong going with this system, and you can proactively fix it. And then of course the robots and the equipments are getting smarter and smarter. They are programmed by computers, and the actual operations are run by computers. So this means that not every single factory can have the maintenance personnel in-house. And the model might be that the factories are not purchasing the robots themselves, but those are leased, or they're taking from an external company who is responsible of the maintenance and operation.
In a modern production line, the actual production line is made up of components from many different vendors. So you may have a situation where different parts of the service need maintenance or support from various different vendors, from various different experts, which may be located elsewhere than the factory, or maybe located in the capital city or in other countries, not right at hand.
And now if we think that as a compound entity, we have the actual data collection and the intranets inside the factory, and there might be different ways of transmitting data. and then you have the point solutions from different vendors or providers. There's also the conflict that there might be some sensitive data that might be flowing across the different components. So that is setting another requirement for the maintenance work that is remote. So thinking of that, Keith, what kind of problems do you see in this kind of setup when there are multiple vendors providing the tools for the assembly line, and then you have the sort of on-prem, the factory infrastructure with its own identities and roles? So how can you handle the identity management?
Yeah, the problem there is you don't want to have a situation where you're creating credentials for each individual vendor supplied component that you're then juggling all those different credentials. So ideally you'd want to centralize that system. You'd want to have a central repository for those external users who have access, a nice, clean, auditable way for to be able to check who has access to what, to grant access at very short notice, and then to be able to revoke that access when it's no longer required, immediately when it's no longer required.
Yeah, and I guess the very critical factor there is that we are in the factories, we are producing some physical goods, and there could be like long supply chains from the factory to the customers and also to the factories. So it's very critical that the assembly line is constantly running and the downtimes are minimized.
Yeah, any fault in the system could result in huge costs, both in delayed delivery of goods, people standing around waiting for the logistics chains to work, but for food, for example, the food can be spoiled by downtime if a refrigeration unit stops, for example. So a lot of the drivers in the factory cases are around reducing the downtime. Accidents do occur, machines do fail, but the faster we can get them back online, the faster the wheels are turning and the factory continues. So you don't want to be in a situation where you're trying to give a third party access during a crisis when they need access now. That's when critical process mistakes are made. They might be given too much access, might be given, in the worst case scenario, given credentials from another user. And you want to make that a formal process.
Yeah. Another angle to this problem really is that when the factories are really combination of different vendors and different tools from different sources. So you need to have a control what kind of activities are done when those maintenance operations are done. And that means that you need to be in control of what kind of data is uploaded or downloaded in the environment and what are the actual actions that are made in the maintenance operations, so that you can be sure that only the necessary information is used in these setups and you know whether your critical assets, data assets, might be escaping your enterprise.
And this is the concept of trust but verify. You need to put your trust in those third-party providers to do their work, but you need to have a way to monitor and make sure that they're doing exactly what was ordered and not taking anything with them when they leave the building. The next case is around maintenance of a software resource, and we're going to use the example of an Oracle database. And Oracle databases are well known to be very, very complex, made up of many different components. And in a production environment, things can sometimes go wrong, and the database is often at the heart of a software service. And if the database is failing, then the whole service might be offline. And that's a time when you might need to call in external help to first evaluate and find out what's the cause of the problem. It might be a problem that's developing over time, a reduction in performance, and you need a specialist to come in and look at optimizing the system, to tune the database or optimize queries to make things work. And often these type of explorative and diagnostic support work needs to be done in situ. They need to be done in the production environment, and sometimes can't be replicated in a test environment.
So the difference here is for the physical factory is that this is normally software on a cloud environment or virtualized environment, and in theory you could define everything to be the same, and you could reproduce the setup in your test lab and try to diagnose it. But we all know that in real life that's not the case. There might be something different in the actual production infrastructure. The physical hardware underneath your virtual machine might be broken, or there might be some performance problems, or the hypervisors might be behaving differently. And it might be impossible to reproduce these problems in your test or simulation environment. So it's critical in these cases to bring the expertise on the production so that they can diagnose whether it's hardware or software failure, or whether it's something in your configuration, and the problem would be just manifesting itself in that real life situation you have in your production.
And more these type of work is done by external resources, because a company themselves are having trouble to hire and retain specialized staff, experts with this knowledge. They're very expensive resources, and they're resources that you need perhaps during the system setup, when the system is changed, but otherwise are only required when something goes wrong.
Yeah, and I guess that is part of the development in software architectures nowadays, that systems are getting more complex, and there are lots of commercial and open source components that are used to assemble these systems together, and it's practically impossible to have all the talents in-house to do everything from the software design to development to operations, and then have the skills to do the diagnostics in the very specific real life loads and traffic patterns your infrastructure might be facing. Other important topic or interesting topic in the Oracle database setup is that normally the databases are the core asset of your company. They contain basically the most valuable information, the data you have. And now we already have seen that in the traditional privileged access cases, that if you have access to the databases, normally you don't have the segregation of data inside the database, but the access controls are done in the application logic that is connecting to databases. And now in the European Union, we have the GDPR that is setting its own requirements for the data and who can access that. And now if we have a setup that the Oracle database needs to be diagnosed, and you need to invite the third-party specialist doing that, you have to pay attention for this sensitive personal information and whether that is exposed, and how can you control the data exposure in this kind of setup.
Yeah, so you need checks and controls to make sure that's all done in a very, very formal process.
Also, one thing with the deployments is that you might be running your database clusters on a multiple cloud providers, or you might have the on-prem and on cloud, and that means that you need to have the controls in place that you can, regardless of network path that the expert takes from his or her workstation to diagnose the database, whether they can access the on-prem, let's say, Oracle database instance, or the cloud host is Oracle database instance, having the means to provide the access in this setup, and then also have the controls in place that you can see what kind of data and what kind of operations are done.
And this use case can be compared to other specialist software services, not only for databases, but typically complex software has its industries specialists who are needed to come in and help at certain times. Good, let's look at the fourth use case, which is around startup DevOps. Do you want to explain a little bit what is startup DevOps?
Yes, so there's actually multiple drivers nowadays in the software development and in the way how software is built and operated. It started with the microservices and with the notation that the developers are actually responsible of doing the operations. And now when they are doing the operations of the software, it means that if something goes wrong in the production, the developers are the experts to diagnose it and fix it. This is a new paradigm. Normally it's deployed in cloud environments. You could easily do it in your on-premise. You could run your OpenStack or other like on-premise cloud infrastructures. But the point there really is that it's very elastic. The number of components is increasing from like individual backend, front-end database server. You might be having hundreds or thousands of services. And also the way how the DevOps works, it means that in bigger companies with the web giants, they are deploying the production 100 times a day instead of doing 2 deployments per year. And it means that if you are deploying something 100 times a day, you can't invite the specialist and stop the production and start investigating. You need to fix it fast, and you need to provide the developers the access to the infrastructure so that they can do their work. And sort of like why the software is done this way. This is simply speeding up the innovation. It gives an advantage for the companies who use this kind of a cloud-native elastic tools, but it sets new requirements how you can operate and what kind of access and what kind of controls you need.
It's common in a DevOps environment that you'd also be deploying not only to one cloud vendor, for example, to Amazon, but you might have services running on different clouds. So you might have a multi-cloud infrastructure where you're choosing the cloud provider who has the cheapest or best component for the use case. And a customer service might consist of many, many different components. So you need to then have privileged access to multiple cloud environments in order to work on a given project.
Yeah, that's right. And also one driver for that is that we have seen some outages for the big cloud providers. So if you really need to have a critical service that is up and running, you might be safer to use 2 cloud providers because it's less probable that both of them would be going down at the same time.
Yeah. And then certain cloud providers don't operate in certain regions, so you may have a multi-cloud strategy to cope with that. The other thing with the cloud is cloud incurs real costs. So if you're empowering your development team to start and stop resources, which may incur hundreds of thousands or tens of thousands of dollars or euros in resources, you want to control who has the ability to invoke those services.
Also, like mentioned with the DevOps model, now the developers have more access to the infrastructure. This is sort of an movement that we used to have traditional privileged access, and those were the system administrators who were operating the infrastructure, and then you had the developers at their own silos. Nowadays, it's not binary. It's not privileged and non-privileged access, but you have the developers, you might have test roles, you have the database specialists, you have the Linux admins with different access needs, and this kind of a binary role model doesn't work. You need to have a flexible model where you can define the roles based on the developer needs and the operation needs.
And more, as we talked about lack of skilled resources, you as an employee might be sitting next to somebody who's being paid according to a contractor who's coming in and completing work, acting like an employee, but is actually not an employee and not to be found in your HR system anywhere. So this mix between employees who are accessing these services and contractors and subcontractors who need access to equivalent services, whilst giving management visibility and audit visibility to follow what they're doing.
Yeah, that's actually a very good point. We have this movement of lean startup where the companies would be concentrating on their own core competencies, and more components or services would be outsourced from external companies or from freelancers. So that mixes the traditional employees on a payroll versus externals, and everyone are operating on the same assets, but maybe with different contracts or legal obligations, or then the compliance requirements if we go into the more controlled environments.
Mm-hmm. And in those situations where you have a subcontractor or a contractor coming in, the contracting firm is best to know how to. They might replace that resource with another equivalent resource at very short notice, and that new person stepping into the office and sitting in the chair next to you needs to get equivalent access at very short notice. So
yeah, I think that's really the key thing, is that since the roles are more dynamic and they're more fine-grained, you need to pay attention that you can easily, in this kind of environments, onboard new persons. You can manage the role changes, and especially when the people are leaving, you can offboard them. Or can you actually make sure that those employees who left your company, or those contractors or third parties who left, they don't have credentials to your production environment?
Yeah. And when they do have credentials, they have credentials which are targeted purely for the resources that they need access to. So this idea of minimum required access is standard practice.
And this is the area where we have seen lots of development lately. The access used to be provided with usernames and passwords, and with the SSH case, those were provided with SSH keys. Nowadays, for example, also with our PrivX product, we are providing the access with ephemeral short-lived certificates. So there's practically nothing that can be taken away, and there are no leftover credentials that could be used later to gain access to the production environment.
So these short-lived certificates mean that even if you do nothing, the access will expire.
Yeah, as a default in the PrivX implementation, the certificates expire in 5 minutes.
Yeah. So even if you leave the door open behind you, it'll lock automatically.
Yeah.
Yeah. Great. Well, following this evolution theme, let's look at the main takeaways that we've had from these examples. And we want people listening today to have a think about their own onboarding process, offboarding, and then managing of roles for the users who have access to the system. So think about what would you do in each of those situations when you need specialist access to an electronic resource at very short notice. How do your processes and policies work, and how in practice does somebody get access to that remote server in a remote cloud environment in a safe and secure way that can be monitored?
And normally there's a business driver to provide the access. There's a reason why a person needs to access. But once the access is provided, there might not be business drivers to remove the access. And in some of our SSH key management cases, we have heard about a consultant who was working for the company, left for 2 years and came back, and still his SSH keys work in the production environment.
Yeah, scary stuff. When there's more and more environments or systems are made up of environments spread throughout multiple different clouds and on-premise environments, then the proliferation of those credentials create a real risk.
Yeah, that's true. And then we are using different kind of credentials for different cloud providers or on-prem. So the number of entities you need to manage is actually huge.
Yes. The second question we have is, when you think about your own system, can you provide single sign-on for on-premise, hybrid, and multi-cloud environments? So does the same single login that you use for on-premise services allow you to move between not only the applications themselves, but also for maintenance access and developer access to the hybrid and multi-cloud environments?
And I would really like to pay attention here also for the privileged access. Traditionally, it has been so that the identity and access management solutions have been concentrating on the end user access and on sort of for the business applications, whereas the system administrators have been living on their own domain. And this actually effectively means that there would be 2 different domains for identity and access management. We believe that there should be only one, and this only one identity and access management system should cover all access, regardless of the actual access protocol that is used.
That makes it impossible to forget about a group of users, and it makes visibility of who has access to what much more transparent.
The third takeaway is the question, can you monitor privileged users? So when your system administrators or database experts are doing something in your production environments, first of all, you want to secure the connection if that's a remote access. So it needs to be encrypted. Then in this setup, how can you see what is actually happening inside the connection? And who is the entity behind the encrypted connection doing the maintenance operation.
And this might mean that you have visibility to see every command that somebody's entering on a command line, or it can also mean that you have a sort of remote desktop log to see what somebody's doing in an interactive session in a user interface.
Right.
Our last question is, can you support third-party use cases? And all the cases we talked about today were involving third parties. So these are people outside of your HR system, people that you trust to help you run and update your services. And can you really support them, or are you relying on them coming to your office physically, them doing shared sessions by remote tools, or are you actually empowering them to do the work themselves? If we use an analogy, if you think of somebody digging a hole with a shovel, do you need somebody standing next to them watching them dig that hole, or can you just empower them with the tools and access so that they can come and dig that hole while you're away and you have the ability to check the hole stuff?
And normally these third-party users are not part of your identity and access management system. Those are somehow external. So how comfortable you would be requesting the change ticket for your Active Directory to add a third-party account? How flexible is your identity and access management system in this kind of setups where you can invite a third party and authorize them to do access to your production environment?
We raised the cases that third party might be a whole organization, which is empowered themselves to choose who within their organization is going to perform a given task on a given day, or it can be tied to an individual. So can you support third-party use cases where you're empowering a third-party partner to manage that process for you, or to individual named users who will come and go? In all of those cases, the point is that access shouldn't get in the way of productive work. So when you need to get something done, you should be able to get fast and secure access in a repeatable and manageable way. That concludes our webinar for today. We're going to invite questions from the audience.
Yeah, so there are some questions online. The first one is that how do you handle different levels of access? There's this principle of least privilege, meaning that you only provide the level of access that's needed to get the job done. Does this solution support that?
Absolutely. The privilege of least privilege is a very important one, that somebody should only have access to the target system that they need to have access to, have the minimum role set to complete a task at hand, and not have any wide-reaching roles.
And I think the important thing here really is to define the role-based access, that you define clear roles, and then from the roles you can easily see what kind of services, what kind of tools need to be accessible. And once the roles are defined, then it's much easier to assign people to the roles instead of starting granting access ad hoc based on the urgency you had.
Yeah, the worst situation, in an emergency situation, someone might be tempted to grant more access than is required just to make sure that the user can get to the place where they need to go. And by having a very clear role model with very clearly defined roles, where there's no doubt about what the role in question grants the user access to do, is part of that.
The next one is actually related to system administrators, because sometimes you have users who need that kind of power access or root access, and otherwise they can't get the job done. And we know for a fact that in the past, these power users or system administrators have been able to create their own ad hoc credentials that basically bypass the existing, let's say, traditional privilege access management solutions. So can this solution prevent something like that?
Well, I guess the key point really is to define the roles that are needed to do the administrative operations. And once you have those defined, you could easily lock down the servers so that ad hoc credentials couldn't be added. In addition for that, let's say like if you really have the system level administrator access to the target servers, then the administrators can do whatever is needed. So then comes the audit trails and monitoring. If you have a clear audit trail that someone got the administrator access, then you know what was the real identity behind that access. And then if something bad happens or there are some unintended changes, you know what was the cause for that.
Okay, and next one is around automation. So you talk about automation. Can you describe what can be automated and what is the benefit, basically ROI or TCO of automation?
I think automation, ROI for automation is all about removing manual tasks, and I think it's a quite simple calculation to work out what is the time it takes a skilled professional to, for example, provision access rights to a user compared to having that happen automatically, either through a provisioning process or through a policy role set handled in software. So it's removing that people time. Inside the ROI calculation, you need to put beside that also the exposure to risk. That if you're doing that in a manual process, you're also opening up yourself to the risk of human error, accidentally giving incorrect access rights or too many access rights, and the related work to clean that up.
Then another aspect for that is that if you use some real credentials to provide access for your cloud infrastructure, and let's say you have 20,000 servers and you need to touch each one of those in order to change the access credentials, and it takes 1 second per server, it's 5.5 hours before you have the access provisioned. And that might be causing some downtime or some other delay in your processes. So therefore, the approach we do with the PrivX is that the actual configuration at the target servers is static. It's configured during the server provisioning time, and we can enforce the new rules on real time as the access credentials are changed in the identity management system.
You mentioned multi-cloud and hybrid setup. So let's say that you're using AWS or Azure servers. Would you still have to use multiple consoles to provide access to those servers, or is there another way to provide that kind of access with this solution?
I guess the key point there is really to define the control point where you define the identity management system, and you could go with, let's say, the low level AWS identity management, but it might be quite complicated to use that for your different cloud providers. So I guess the approach, for example, Ubisecure is using is to use a higher level abstraction, use OpenID Connect and define the rules there.
Yeah, and we can provide high level roles to those services, for example, Amazon or Azure, which then within their own services, they control permissions to what those roles mean inside their own services. So there is kind of a layered approach for those cloud services, what a role in an organization's identity management system means, and what role that enables them to take on when they're accessing a remote service.
And the final question is that who is the customer in the Industry 4.0 case?
That example is a real use case from one of our crypto auditor customers. The crypto auditor product can be used to monitor the encrypted connection, and that was used for the remote maintenance of a robot on an assembly line. Unfortunately, I can't disclose the name of the customer.
All right. Thank you. I think it's time to wrap up the session. And if you want to schedule a demo with us, which we strongly encourage, you can contact me directly or visit our respective website. You can find a contact form there. You will also receive a follow-up email with more instructions on how to get in touch with us and how to book a demo. So thanks a lot for attending. It's been a great evening, maybe morning in some other places. And have a great day. Thank you.